All right, so today we're going to be calculating the volume of a rectangular prism with fractional edge lengths. If you're like, oh, rectangular prism, what is that? Well, just remember it's just a rectangle, but then it's a prism, which means it's a 3D shape like the ones we were working with the other day. Obviously, this one's not the best rectangular prism I've ever drawn, but you get the idea. Okay, so let's go ahead and jump into this. All right, so we want to know which one of these would hold more 1 inch by 1 inch by 1 inch cubes. When I'm talking about a 1 inch cube, all I mean is that I have a cube and it's 1 inch tall, 1 inch long, and I guess 1 inch wide. Okay? So I want to know how many would fill up each one of these. Which one would fill up more? So if we think about it, let's start with one at a time. We want to fill the entire thing. So I want to think, just like we did on Tuesday, how many across, how many back, how many up? Well, if they're 1 inch cubes, well, that's pretty simple. That means across the front, there's going to be 10 cubes. Because it's 10 inches and they're each 1 inch. So obviously 1 fits into 10 times. If we go back, we would say there's 4 cubes. And so then going up, there would be 6 cubes. So it means if I do like a layer, right? Let's go ahead and fill this across. One layer in the bottom. There's 10 down here. There's 4 over here. That means total in that entire layer, there are 40. Right? Because there's 4 rows of 10. So you can think of that as 4 rows of 10. So there's 40, but then it goes up, it goes like this. There's 6 rows. And each one of these layers, there's going to be 40, 40, 40, 40, 40, and 40. So 40 times 6, that means there's going to be 240 cubes in this one rectangular prism. So what about this next one? I'd encourage you to think, how many will there be across? How many will there be back? How many will there be up? Go ahead and see if you can figure that out on your own. Remember, they're 8 inch cubes, so it's going to be 8 cubes across. It's going to be 5 cubes back. And it's going to be 12 cubes up. So that means up across the front here, I've got 8 on one layer and 5 back. That means in a single layer, there are 40 again, because 8 cubes times 5 cubes, there's 40 cubes per layer. But then I have 12 total layers. So I have to do 40 12 times. 40, 40, 40, 40, 40, 40, 40, 12 times. So I have to do whatever 12 times 40 is. And think, I know 12 times 4, that's 48. Then I just add a 0, so 480 cubes. So obviously, this one's going to fill with more cubes. But this is the most basic thing. We have a regular cube. It's 1 inch long. There's not as much thinking going on here. We're going to change the size of this cube. So instead of, you don't have to write this down. Instead of our cube being 1 inch here, 1 inch here, and 1 inch there, we're going to cut it in half in every way. So it's going to be half as tall, half as wide, and half as deep. So we're going to fill it with this cube instead. So we're going to focus on this shape, but now it's 1/2 inch by 1/2 inch by 1/2 inch. Okay, well that totally changes this. Now let's think across here. If I think across, I have 10 inches across. 0 all the way to 10. Now instead of 1, it's going to be halves. So if I do 1, it'd be 1, 2, 3, 4, 5, 6, 7, 8. If we did 1s, obviously there's 10, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we're doing half units now. So that means it's 1, 2, 3, 4. So again, 1, 2, 3. Here's my whole number markings. So it's 1, 2, 3, 4. These are halves. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 20 cubes across. And why was that again? Well, because we're not using 1 inch by 1 inch by 1 inch cubes. We're using a ½ cube. So that means more are going to fit because it's smaller. So it's going to be 20 cubes across. Let's think about back. Back we have to go a total of, we can look at our shape, we go back 4 inches. So 0, 1, 2, 3, 4. 1, 2, 3, 4. Remember, it's a ½ inch cube, so it's only going to go 1, 2, 3, 4, 5, 6, 7, 8 cubes would fit here. So 8 cubes back. Well, and what about up or tall? We have to go 6 inches up. 0, 1, 2, 3, 4, 5, 6. And again, ½ inches, so we have to count 1, 2, 2 halves, 3 halves, 4 halves, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 cubes back. So you notice if we cut the size of the cube in half, it doubles the number that'll fit. All right, so it looks like we have 20 cubes across times 8 cubes back times 12 cubes up. And that'll tell us how many fit. So 20 times 8, that's 160. Now I just have to do 160 times 12. 0. 2 times 6 is 12. 2 add 1 is 3. And then I need a placeholder 0. Now 1 times 0 is 0. 6 and 1. Add it up, I end up with 0, 2, 9, and 1. So it looks like this would be filled with 1,920 ½ inch by ½ inch by ½ inch cubes. So that's a lot of cubes. Now, for example 2, it's going to be even different, even more different. So this time, it's going to show you a shape like this. It wants to know for a cube that's 1/4 of an inch. Oh my gosh, it's getting even smaller. So now, instead of this ½ inch cube, instead of a cube that is measuring 1/2 inch by 1/2 inch by 1/2 inch, it's going to get even smaller for its volume. So it's going to be, if it's 1/4, how does a fourth compare to a half? A fourth is this big. It's a half of a half. So here is our 4th size unit cube. So we should have more. Well, no, I guess we're not doing the same shape. We're going to have a small cube here. All right, here it is. I want you to try it. Figure out how many, well, what's the volume of it, and figure this out. Okay, now it's asked for the volume first. Remember, I find the volume by taking the length times the width times the height. Well, what is that? My volume is 1 1/2 times 1 times 3 3/4. Okay, now remember to multiply mixed numbers. And all I do is change these into impropers. So 1 1/2 would change to 3 halves. 1 is just 1/1. And then 3 3/4 would be 15/4. If you're wondering how I got those, remember the work in a circle method. You multiply and then you add. Pretty confusing. It's all right. So if I multiply here, that doesn't change anything. 3 times 1 is 3. Times 15 is 45. 2 times 1 is 2. 2 times 4, that's 8. So it looks like the volume is 45/8. That's pretty weird to think about. So instead, I might think of it as 8 fits into 45, 5 times, with 5 left out of 8. So here, this is my volume. Now we're going to figure out how many 1/8 cubes can fit into it. Well, we could do we can do it 2 different ways. The way we just did it, which is by figuring out how many cubes fit across and back and up, or I can simply take my volume and divide it by the volume of the little cubes. And what's my little cubes? They are 1/4 times 1/4 times 1/4. And that's going to be 1/4 times 4 is 16. 16 times 4, that's 64. So that's my volume of each little cube. So all I do is I can take 5 5/8 and divide it by 1/64. You might be thinking, whoa, that is a messed up problem, Mr. Schneider. Well, here, just change this into an improper. 5 times 8, well, we already know it. It's 45/8. And then if we divide by 1/64, remember this is our do now from yesterday or from Tuesday, multiply by 64 over 1, and we should get our answer right like this, over 8. 45 times 64. And so 4 times 5 is 20. 4 times 4 is 16. 16 add 2 is 18. Placeholder 0. Got my math, I'm working it out. 270. And so here we go. Whoa, 2,880 over 8. That's a big division problem, but not too bad. I can handle it. 2880 divided by 8. 8 fits into 28 3 times. And then 8 fits into 48 6 times. Oh, good. Looks like it's going to work out perfectly. And then 8 fits into 0 0 times. Nice. Okay, so this equals 360, which means we'd have 360 cubes could fit inside of it. Okay, so let's go back and rethink this. That was a big, juicy, meaty problem. Okay, so first, let's think about what we did on the previous page. On this page, we had this shape. And we were filling it up with these little 1/2 inch cubes. So I had to think, how many could fit across the front? How many could fit back? How many could fit up? I found out 20 fit across, 8 fit back, 12 fit up. Now I just did the last one a little differently. Instead, I took the whole volume, right? And I divided it by the volume of the little cube, volume of little cubes. And remember, my cubes were a different size that time. They were 1/4 of an inch. They were even smaller than the 1/2 inch ones. But we could have done it the same way and still gotten the same answer. In fact, I'll prove it to you right here. So again, we have this shape, and I can think across, I can think back, and I can think up. How many are going to fit? Well, across I have 1.5 inches. So it looks like that, 1.5 inches across. Going back, I just have a single 1 inch, so 0 and 1. Going up, I have 3 3/4 inches, so it would look like this. And so I just have to ask myself, this is a 1/4 size cube, 1/4 by 1/4 by 1/4. So how many would fit across? Well, here, across would fit 1, 2, 1/4 is a half of a half, 3, 4, 5, 6. So 6 across. How many would fit back? Well, it's 1/4, right? So 1, 2, 3, 4. 4/4. So 4 back. And how many up? Oh, there's a lot more up. Remember, in each one, there was 4, 4, and 4. But I need to go, my up is 3 3/4, right? So this is 12. But then I have up to 3/4, which is this little notch. So 13, 14, 15 up. All right, well, what do I do with this? Remember, I think, well, 6 across and 4 back, that means each layer is 24. But I have 15 of those layers. So I have to do 24 times 15. 5 times 4 is 20. 5 times 2 is 10. Add 2 is 12. Placeholder for the 5. Multiply with my 1, I just get the same thing. Oh my gosh, I get 360, just like we found out here. So it doesn't matter which way you do it, it just depends on what information you're given. That might be a video where you have to pause a lot and go back and figure out what was going on. There's all kinds of stuff. Huge, chunky, meaty, difficult video. Hope you hung in there.